What's going on, everybody? Welcome back to the channel. We have this interesting question that says find the value of x given that 8 to the x plus 27 to the x all over 12 to the x plus 18 to the x is equal to 7 all over 6. So our first step will be for us to break down each of these terms. So 8 is the same as 2 to the power of 3. And from the question, it is raised to the x, plus 27 can be written as 3 to the power of 3. And from the question, it is also raised to the power of x, all over. Now the denominator, we have 12. 12 is same as 4 times 3. And it is raised to the x. Now let me use a dot instead. So I'm going to be putting a dot here. Good. And it is raised to the power of x. Plus, what about 9? 9 is same as 9 times 2. So, and this is raised to the power of x. So that is 18. And this is equal to 7 all over 6. Now, we can apply the law of indices, which shows that since the powers are multiplying, we can switch their positions. So this can be written as 2 to the power of x or raised to the power of 3. Good. And then plus, this can be written as 3 to the power of x or raised to the power of 3. Switching the positions all over. Now for the denominator, we're going to be distributing this exponent, which is this power, to 4 and 3. So it can be written as 4 to the power of x times 3 to the power of x. Plus, we do the same thing here, distribute the exponent, so this becomes 9 to power x times 2 to power x, and this is equal to 7 all over 6. Now, we know that 4 is same as 2 squared, so I'm going to be putting 2 squared here in place of 4, so 2 squared, that is it, and I'll do the same thing to the 9. We know that 9 is same as 3 squared. Very good. Very good. Now, just as we switch the positions of the powers here, we're going to be doing the same thing here and here. So this becomes, we have 2 to power x, all raised to the power of 3, plus 3 to power x, all raised to power 3, all over. Now, the denominator, switching the positions, we have 2 to power x, all raised to the power of 2 for this, times we have 3 to power x, and then plus, switching the position here, we have 3 to power x all raised to power 2 times 2 to power x. Good. And this is equal to 7 all over 6. Now we have some things common. We have 2 to power x and we have 3 to power x all over. So because of that, we can say that let 2 to power x be a and let 3 to power x be b. So that means this will be a to power 3 plus this will be b to power 3 all over. Now the denominator, this is a squared times this is b plus this is b squared times a. Very good. So this is equal to 7 all over 6. Now from the numerator, we can see that we have the sum of two cubes, which has an identity of a plus b times a squared plus b squared minus ab. Good. And this all over. Now the denominator, you see that a and b are common, so we can factor out a and b. Now a squared times b divided by ab, we're going to be having a plus b squared times a divided by ab, we're going to be having b. Good. And this is equal to 7 all over 6. And now notice that a plus b cancels out a plus b, so we have a squared plus b squared minus ab on the numerator all over ab on the denominator, and this is equal to 7 all over 6. Now let's separate the fraction. So we have a squared divided by ab plus we have b squared divided by ab minus we have ab divided by ab, and this is equal to 7 all over 6. And then simplifying further, you see that a cancels out a from here, so leaving behind a all over b. So I'm going to be writing a all over b here, plus b cancels out b from here, so leaving behind b over a, so b over a, minus, now ab divided by ab is 1, and this is equal to 7 all over 6. Very good. Now I'm going to be using substitution here. We can say that let a over b be equal to y. So that means this is y plus, since b over a is an inverse of a over b, that means I'm going to be writing b over a as an inverse of y. Good. Minus 1 equal to 7 all over 6. Now let's clear the fraction. We have y times 6 on the denominator. So y times 6 is the LCM. So we multiply through by 6y to clear the fraction. So we have y multiplied by 6y plus we have 1 over y also multiplied by 6y. Now we have minus 1. We also multiply by 6y, and then we have 7 over 6. Remember, we multiply by 6y. Y times 6y is 6y squared. Now see that this y cancels out this y, so 1 times 6 is 6, and then minus 1 times 6y is 6y. This is equal to, now 6 here cancels out this 6, so 7 times y is 7y. Now let's move everything to one side of the equation. So we have 6y squared minus 6y. And when I move 7y to the left, it becomes minus 7y. Here we have plus 6 equal to 0. And then this becomes 6y squared minus 6y minus 7y is minus 13y. And then plus 6 equal to 0. So we have a nice quadratic equation. Well, this equation can be factorized. So the first thing we do is multiply 6 times 6, and we're going to be having 36. So what are the factors of 36 that we can use to satisfy this equation? The factors that we're going to be using will be -9 and -4. Why? Their multiplication, -9 times -4, gives positive 36, which is the term here that we got after multiplying. And then their addition, -9y plus -4y, gives -13y, which is what we have here in the middle. So this factor is very much correct. So we have 6y squared. Now we're going to be replacing this with this, minus 9y minus 4y, and then plus 6 equal to 0. Now notice that 3y is common here, so we can factor out 3y. Open bracket. 6y squared divided by 3y, we have 2y, minus 9y divided by 3y, we're going to be having 3. Minus, now 2 is common, so we can factor out 2. Now open brackets. Now -4y divided by -2, we're going to be having 2y, and then 6 divided by -2, we're going to be having -3. Good. This is equal to 0. Now I'm going to be writing the terms inside of the bracket since it is common. So this is 2y minus 3, and then open another bracket. Now notice that this will remain, which is 3y, minus, here we have 2 remaining here. Very good. And this is equal to 0. So we have two cases. We have 2y minus 3 to be equal to 0. While here we have 3y minus 2 to be equal to 0. From here, you see that y will be equal to 3 over 2, making y the subject. Here, you see that y will be equal to 2 over 3, making y the subject. But recall something, that we have a substitution, which is, we said let a over b be equal to y. Good. Now we're going to be putting each of these y's here. So here we have a over b to be equal to, this first y is 3 over 2. Good. Y a over b equal to this second y is 2 over 3. Now also recall that we said a is equal to 2 to the power of x and that b is equal to 3 to power x. So let's fix them here. A is 2 to power x, all over b is 3 to power x. So this is equal to 3 over 2. Now here, a is 2 to power x, all over b is 3 to power x, and here it is equal to 2 all over 3. Good. Now from indices, since the powers are common, this can be written as 2 over 3. Good. All raised to the common power of x. This is equal to, now from here, we can twist the position by switching it. So this becomes 2 over 3. And when we switch a position between the numerator and denominator, it becomes an inverse. So we can put -1 here. Good. From here, we apply the same thing, 2 over 3, all raised to the common power of x, equal to, here we have 2 over 3. 2 over 3 to power 1 is still the same thing. Now notice that the base here and the base here are the same, so we equate the powers. So the power here is x, equal to the right hand side, -1. The base here and the base here are the same, so we have the powers equating, x equal to 1. So the values of x are x equal to -1 and x equal to 1 as solution to this equation. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up, subscribe if you haven't, turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.